Hey friends, it's Mr. Maytash here. I just wanted to shoot you a little video about day 1 and day 2. You can see on the screen there that I've boxed it off there. Day 1 and day 2, meaning their notes and their homework, will be due on Wednesday of this week. I will be back Wednesday. I'm not here today. I'm not here tomorrow. Technically, tomorrow you will not really have math class. When you come to math class, you're going to be taken down to the CCC, the Career and Counseling Center. So this will be your responsibility for homework, to watch this video, get the notes that you need, and then use them to complete day 1 and day 2 homework. All right, so here we go. We're just going to walk through the day 1 notes. We're going to walk through the day 2 notes together. I'll try to give you as much detail as possible. Use these notes to then go back and do your homework for day 1 and day 2. All right, here we go. I'm just going to fast forward. Oh, P.S. The spiral that you guys got on Friday is also due Friday of this week, so make sure you're working on that if you were to complete day 1 and day 2 at some point today or tomorrow. All right, so here we go with day 1. So this unit is all about inequalities. Inequalities are just like equal signs. They're just like equations, except for their statement is not that the two sides are equal. Their statement is that the left and the right hand side might be greater than or less than each other. So as you're watching this and I'm talking through it, all you have to do for this section is state if it's true or false. Make note of what less than symbols mean, what greater than symbols mean. If you look at part A, that says 7 is greater than 3. Part B says 0 is less than 10. So that's what the direction would be in terms of what the symbol means. In letter D, you notice I circle the equal to portion, because if it's less than or equal to, that allows it to be true there. That's really all that's happening in this section, is stating if it's true or if it's false based on the symbol. So you just have to be really good at getting the symbol down. In exercise 2, now we're looking at two numbers again, -8. Less than 4. You can see I'm writing here, read it aloud. So out loud to yourself. Say that and use the symbol and the words that follow it. So -8 less than 4, is that true? The best way, at least in my opinion, to figure that out, draw yourself a number line. Put -8 where it would be, put 4 where it would be. The one that is furthest left, as you can see I'm denoting there, is the one that is less than the other. So in this case, this is true because -8 is the furthest left on the number line. So that would be there. Exercise 3, same exact stuff. True, false, true, false. You got to figure out what it is. I'm going to suggest, and I'm doing it here, draw yourself a number line at the bottom of your page. That way we can mark off where all these numbers fall and be able to make pretty easy comparisons. So once I get through this number line here, then we can then compare, and I believe I color-coded here for each number. So if we have 3 versus -4. Oh, and this might be helpful to you too, so I would copy this down. Less than, greater than, knowing which one is which. I always say for less than, if you raise your left hand and make an L, that kind of looks like a less than symbol. So left hand, less than, always a good thing to know. So this one's true for part A. For part B, again, putting the two things on the number line, it's saying that -5 is greater than -3. That's not true. And then letter C, same concept, just reading it to yourself, trying to figure out if it's true or false. That's it. So that's all page 1 of day 1. Like I said, not too crazy, nothing too outstanding for that. So exercise 4 is the same type of concept, except for we're going to test an x value and see if it's true. So it's not going to be presented to us as just numbers. They're giving us an inequality with x's. Your job is to take an x value, replace it, and see if it's true or not. So you're seeing me do this with 10, as they're giving you in part A. Simplifying it, I would even suggest going right to the calculator once you've plugged in the number and seeing if it's true or false. So 24 greater than or equal to 21, absolutely true. So that means that number 10, the 10 that you plugged in, is a solution. So remember, solution versus non-solution. If it's true, yes, it's a solution. If it's false, then it is not a solution. So in part B, same concept, except for we're plugging in 5 here. And 9 greater than or equal to 11. No, that is not true. So that means that this is not a solution. X equals 5. No good. Okay, so C and D, I'm going to leave for you guys to attempt on your own. Just plug those numbers in, see if they work or see if they don't. In exercise 5, it's going to be more of the same. So down there, you have these larger inequalities, more complex inequalities, but all they're asking you to do is take an x value, put it in for x, and see if it's true or false. See if that is a solution for the inequality that's given to you. So I'll just do this first one to show you what I mean by take all the numbers and plug them in. Sometimes they give you 3, sometimes they'll give you 1 number to plug in. So all you're doing is taking the number, plugging it in, see if it works. That's it. So as we simplify, and I'm going to kind of short-term this, 6 ends up being greater than 3, true. 4 greater than -1, true. This last one ends up being, I believe, 18 is greater than 27. And there it is. Now, in this case, false. So that means 1 and 0 would be solutions for the inequality, whereas 7 would not be. And that's about it for this particular day. Again, a lot of true and false, a lot of making sure things are solutions versus non-solutions. Don't have to solve anything in particular. You're just trying to plug in and see if we have solutions. That's about all it for day 1. Your homework's going to be a very, very similar setup to what you had on the notes. So I would try these out, these last few here, for B, C, and D, and then go to the homework. Again, it's going to be a lot of the same stuff. All right, so on to day 2 notes. Remember, this video is for day 1 and day 2. It's all cramped together, so if you want to do one at a time, just press pause here or X out of it now and come back to it when you get back into it for day 2. So exercise 1, you're taking the inequality of 4 less than 8, and we are going to manipulate. We're going to change both sides. Remember, properties of equality, doing it to both sides, and just see if things remain true. So notice in part A, we're adding something. In part B, we're subtracting something from both sides. C and D, we're going to multiply on both sides and then divide on both sides. And as you'll find out, no matter what we do, no matter what operation we apply to both sides, we end up with true statements all along. So that just means with inequalities, if you do the same things we would with equations, meaning do something to both sides, it's not going to change the equality of the inequality, with the exception of what you see here in exercise 2. So take note of what they're asking us to do differently here. You're still multiplying by something. For part B, we're going to end up dividing by something. But what that something is why the change happens, why this specific thing needs to be addressed. So when we multiplied by a negative number, that's why these things end up being false. Because by multiplying a negative, the signs change, and then the inequality itself doesn't remain with its truth value. So if at some point you ever multiply or divide, and this is what this star is going to mean for you, and you're going to write this down. If you multiply or divide by a negative number, you need to switch the inequality symbol, meaning flip it around. Otherwise, to solve an inequality is the same thing, same steps that you would do to solve an equation. So there's really no difference. Besides moving things back and forth, combining like terms, simplifying, all those things you're still going to do. It's just that if you end up multiplying or dividing by a negative number, on both sides, mind you, then you need to flip the sign. Oh, there's a little piece of on both sides. All right, so notice that distributing, putting things from side to side, adding 8, dividing by negative, like all these things are the same exact steps you would take for solving an equation. Now with inequalities, the only thing we have to worry about really is this end piece, is when we divide by -2, it's not going to remain as a greater than, it's going to flip around and become less than. So it becomes x is less than -8 instead of x is greater. So it always flips if you divide or multiply by a negative number. Okay, so this one's just combining like terms. You get to it pretty quickly. Again, that symbol, since we divided by a negative, is going to flip around, becomes greater than or equal to. Okay, interval notation is something we're going to see throughout this unit. It's really just a way to represent a solution for an inequality. I think you should write this at the top of your paper, smallest comma largest. So interval notation essentially is used when we have a clear starting point and a clear ending point to a set of solutions. So let's just say for the inequality we just had above, it was x is greater than 5 or so. That means 5 is the smallest number in that set, because 5, 6, 7, 8, 9, 10, all those numbers that are greater are available to be solutions. So you just have to be aware of when the starting point, when the smallest one is, and when the end point is, and that's how you can use interval notation. So to make this a little more clear, you're just going to fill in once with a verbal solution. You're going to write it as an inequality. So looking at the number line, that's on -1. Since the circle is filled in, that means it's a greater than or equal to, and since it's going off to the right, that's a greater than symbol being used. Excuse me. So the concept of smallest to largest, look at where -1 is in terms of the solution. That is the furthest thing left, everything else is to the right. That's why the arrow is going that way. So the smallest part of the solution set is -1, and then you'll see it goes comma infinity, with the symbol of infinity having parentheses around it, because we don't have a stopping point for infinity. By the way, the square brackets versus the parentheses brackets, that is just based on if it's included in the set or not. So in here, sorry guys, I'm still a little sick. Less than 1, you see the dot is at 1. It's not filled in, so that would just mean that it's not included. I'm just going to rewind the video just a second so you can see the brackets and the parentheses getting played out. So just bear with me. You can see where -1 has a bracket around it here. That's because on the number line it's filled in. It's also because, and you can see the dotted line connecting them, the greater than or equal to symbol will always give you the brackets. Now if you go down the page where we saw a less than 1, notice the dot is not filled in. Notice that it's just a plain less than. So when we get to doing our interval notation, negative infinity is just representative of how far left that's going down the number line, and then 1 is where we kind of stop when we come to the right. The reason that it's a parentheses is because that dot is not filled in and the symbol is just a plain less than. So something to keep in your mind as you're going through the rest of these. Speaking of going through the rest of these, now you're going to solve these inequalities, and you can see me doing this now. Once you get your solution, once it's x is greater than, less than, whatever, x is greater than or equal to 2, you write your verbal solution. So basically, if you just read the symbol out loud to yourself and write those words down, that's what that solution will look like. Then on your number line, you can number it off specifically, or you can just throw your solution down the middle. And then again, open dot for regular less thans and greater thans, closed dot if it's a greater than or equal to. So you'll see we'll have a closed dot there. Arrow pointing to the right because all things greater than 2 are in that direction. Then interval notation, again, you're seeing pop up. We'll come back to and talk about that a little bit more on Wednesday, so don't panic if that interval notation is not sticking with you. And then, really, guys, the rest of this page and the rest of day 2 is just solving, representing it on a number line, representing it on in verbal form, representing it in interval notation, just repeating the process so you can start to get some fluency.